Is it possible that space AI, we're talking about AI data centers in space and eventually on the moon, is it possible that it's even bigger than Optimus? Think about that for a second. Most investors are finally waking up to the idea that humanoid robots will become the largest industry in human history. Yet somehow, there's a Musk project that could surpass even that. Our guest today, Brian Wang, has run the numbers, and he's here to show you why space-based compute may be the real singularity, a shift so big it feels like a magnitude 23 shock to the entire tech world. Why does owning the largest compute capacity matter? Because every major tech company knows the same truth. Whoever controls the biggest AI data centers controls everything that sits on top of them. One example you'll see today, xAI's Grok 4.2 quietly mastered real money day trading, outperforming every other LLM. And that's just the faintest preview of what's possible when the smartest AI isn't just on Earth, but in orbit and on the moon. We have Brian Wang joining us today. He's a futurist thought leader and a popular science blogger with 1 million readers per month. Check out his YouTube channel at NextBigFuture and his blog NextBigFuture.com. It's ranked #1 science news blog. Welcome, Brian.
Great to be here, Herbert. Exciting stuff.
Very exciting, very big. And the things you were predicting earlier has come true. You were talking about how SpaceX is a big deal, space-based AI data centers. All of a sudden, this week, everybody's talking about it. But you have a very important, shocking take. You have to convince me, but you're saying that space AI is bigger than Tesla's Optimus humanoid robot. How is that even possible? But walk us through.
Okay, so here we have, of course, the two things. On the left, we have the Starlink satellites, the version 1.5. The bigger one, the version 2 minis that are up there now is over 9,000 total satellites up there right now. And the version 2 mini, about 7,500 of those. And then next year, they'll start making version 3 minis, version 3 full size, that will launch from Starship. And they will make a version that will be for communication. And then they'll also make one for AI, where they'll put the AI chips. Elon's given us more details about that, which we'll go over. And of course, we have our lovely Optimus Tesla bot, which will still be important, still be insanely huge, but it's just that the other thing is so much bigger, and I'm going to describe how big that is. So
did you say that you are saying that a Starlink satellite, version 3 will launch next year, but there's a part of a version of that that's going to be AI data center already next year?
I think they will launch some demo versions of it next year, like a load of some number. 10, 100, some number that they will launch next year. Yes. They will launch AI data centers, because basically for a satellite, you have, the power system, the communication, the control stuff, and then you have the main payload part of it that's doing work. And currently they're doing all communications, either high-speed, high bandwidth internet to sell dishes, which is a main product, and they have some that do direct to cell phone communications. But if I took out the communications part and then put in just AI chips, then those systems could handle those AI data center chips and would still use like the communications. They have laser communication between Starlink satellites. So you could still use 20% or more of the satellite. That would be basically the same. I'm just taking out like a module and then putting in another module into it. That would be, so it perfectly work fine. The test has been done by Google, where they have a team that's worked on it. They published a 19-page paper called Google Suncatcher. They tested their TPU chips, high bandwidth memory, everything in a rack. They shoved it against a particle accelerator to mimic radiation over a number of years. So they hit it with more radiation than we normally hit it with, in order when it was in space, to show that over a number of years it can handle it. They found that it had 1 in 10 million errors. So your software can manage that level of errors for AI inference. So basically, I take it. The satellite has some aluminum shielding around it. So basically, it's acceptable levels of error, unmodified chips, unmodified memory. I just shove it in there, launch it. We're good to go. So
Gotcha.
it's so simple that we
Wow.
were already done. We're just adding on top of it.
Wow. Okay. This is surprising that it's actually possibly even a small number next year already. I was thinking this was going to be 2 to 3 years at least.
Right. Of course, everything hinges on Starship. So we've had 11 whatever launches, a lot of explosions, people saying, oh, it's not quite working, but we have had 3 landed boosters of the lower stage. We caught 3 of them, that amazing visual of them catching them. And they've relaunched 2 boosters, right? And then we haven't landed the upper stage, the Starship part, and they've purposely not gone to orbit with it. But we have launched 2 batches of dummy version 3 satellites. So in a normal situation, you would launch a rocket, a non-SpaceX rocket, you launch it, you release the payload, and then everything's destroyed because they would crash the rocket and nothing's saved, right? So Starship just launching to orbit, releasing payload, and then not catching the booster, not reusing the Starship, that alone would get to $500 per kilogram of launch, where basically it would be half the price of a reusable Starship Falcon Heavy, right? Which is already the cheapest thing. So even without reuse, just launching and dumping out payload, it would be cheaper. But with reuse, because they've done several hover landings, so they will be able to catch the upper stage. They've already proven they can catch the bottom stage. The bottom stage catching and reuse would get them, if you had 10 reuses or something like that, you would get down to $100 per kilogram or so, which is below what Google calculates as the threshold of $200 to do cheaper than Earth-based data centers.
Gotcha.
So you cross over without using the upper stage. But SpaceX wants to use both upper stage and lower stage because if I want to make, say, 60 Starships and boosters and reuse them 50 times once a week,
Yeah.
that's 3,000 launches, right? That 3,000 launches is about what we need to launch 100 gigawatts into space. The 100 gigawatts being our largest data center in the 1 gigawatt range, like XAI Colossus 2, right? Those data centers at 1 gigawatt cost about $50 billion. 100 gigawatts of data center is $5 trillion. I expect them to economize on that and not use NVIDIA chips and save about 20 to $30 billion. So you're getting down to 20 billion dollars per gigawatt or $2 trillion for the 100 gigawatts. But 3,000 launches, and we'll have another video where I'll go over the details of like launch towers and how I can get that. But that is doable 2030, 2032. So
Okay.
yeah, and then that means huge things because those numbers, people don't understand what that means, and I'll explain what that means. Yeah, so the size of it, we have the International Space Station, the V3 on the right, it'll be all one set of panels, but basically, and they're going to increase the power on the version 3. Elon said he's going to go to 150 kilowatts per satellite. So the amount of solar actually may end up being more approaching each one of the 4 sets on the space station. And then you have a football field down below to show you that's roughly the width of a football field, maybe a bit wider,
Right.
and then
Wow.
length about
Yeah.
10 yards, right? So,
Gotcha.
and you're putting like 100, 200 of these satellites into each Starship launch when they get them fully loaded. So if you lay them end to end, 10 would cover, when they unfold, would cover the football field. And then you'd have 10 football fields or 20 football fields worth of
Wow.
satellites for each load that you're launching out there.
This is huge. Okay.
Right. This is huge. And then go to the next
That's
one.
a lot.
Yeah.
Wow.
So it's well beyond Optimus, because Optimus is only replacing labor, right? And then
Only
you have
replacing labor,
only replacing labor,
which is
right?
the largest dam in the ever in history of Earth.
Right, right. But energy
Humanity.
on Earth cannot be built to match the energy in space. Space
Right.
agents will beat Optimus because energy can be built to power. We cannot build enough energy on Earth to power enough Optimus with their AI chips. Like basically, you kind of cap out at 1 billion Optimus. Maybe if I can make more energy efficient Optimus, I can get to 10 billion. I run into power problems running, although I can choose to not run the distributed AI, because Elon talked about using distributed data centers using the Optimus to run the chip. If the Optimus is only doing the labor part and not acting as a distributed data center, then it could be only using power like 10-20% of the time. But anyway, it's a power problem to use more Optimus. You can build more Optimus and power on Earth. It will just take time. We can build I'm going to go into why we can build the power in space a lot more and why the cap is a lot higher. But I think the main value ultimately will become the AI chip. So each Optimus AI chip, it could be 20% of the value of Optimus is a chip. And then the chips, if I have more of them, it's basically like, that GDP, gross domestic product, is, you can calculate one way is number of people, 8 billion people, times an average per capita amount of productivity earnings, say $10,000, $20,000. If I end up having 10 billion chips and they're each making $20,000, then you have a crossover point where it's number of chips instead of number of people that becomes the dominant thing. So if I go to a trillion chips, 100 times more than people, then the economy is dominated by chips and AI. This goes to also in Silicon Valley, where I've been for the last 30 years. Silicon Valley, when they created the internet, when they created cloud computing, all this stuff, it was once the unit economic works and the scaling works, then I scale infinitely until the unit economic breaks, right? If it doesn't break, I just keep scaling up more and more, right? So energy and AI will grow from 30% of the economy towards 99% because you decouple the AI and the energy from human in the loop, right? So then I can, previously all the automation of programming, IT, all that stuff, we still needed developers. We still needed people to be involved. So then as that grew, the people labor component grew. So you're paying more salary to people, you're doing other stuff. Are not fully decoupled. It's just like autopilot or like FSD. Robotaxi, the value changes because I go fully autonomous. So that's why going fully autonomous, and then it becomes purely the number of chips all delivering value, if the unit economics are there, that you get this infinite money glitch. What Elon described, the infinite money glitch, that is what I'm trying to describe in more detail, is the infinite money glitch that this is going to be.
Okay, I think I'm getting it actually. So let me repeat what I'm hearing. So first of all, Optimus is addressing the largest market ever because it's replacing labor.
Right.
That's $44 trillion, I believe. Okay.
Yeah.
And then you've got AI energy. So AI is moving because yes, there's going to be massive data centers on Earth, but now the largest data centers, the most compute eventually will be in space.
That's right.
That you've explained it, others have explained it, that it's more economically possible there. And you've got unlimited energy because the sun, it's always pointing at the sun.
Yeah.
It's got, I don't know, you can tell me, about 8 times more energy. And so it's free.
Right.
The sun is free.
Right.
And so if you actually get to almost no cost energy, and you have all the AI, and then together that is maybe larger than Optimus.
That's right.
That makes sense.
That's right. And someone else who agrees with us is Elon Musk.
Oh.
Yeah.
Okay.
So I wrote some stuff about the scale, getting to million terawatts, perawatts, exawatts. You talk about exawatts, which is 1 million terawatts. And so I was breaking down the various ways that synchronizes, aligned with what he's saying, and how we were going to make data centers on the moon and make fabs and do all that kind of stuff, which we'll go into more detail, right? Hundreds of fabs on the factory of the moon. And then he described that, yes, lunar factories and mass drivers will get us to 100 terawatts per year. Go ahead.
Okay, so exawatts are not your time. You replied to that, and then he replied to you.
That's right.
Saying lunar factories and mass drivers get to 100 terawatt per year.
Right.
So, yeah.
So in terms of the scale, and we'll go over this a bit, is that if you talk about constant power generation on Earth, we have about 3,400 gigawatts, or 3.4 terawatt hours, terawatts on Earth, all of it right now. So if Elon can achieve his goal of 100 terawatts, that would be 30 times more power than on the Earth every year. So,
And energy is productivity. Energy
yeah,
is everything.
and energy and
Gotcha.
computers, everything. That's right.
And it's free.
And it's free, and it'll be free. Yeah, well, free other than the capital cost of building it. Yes. We can go to the next
Gotcha.
slide. So first, we'll go over a few things about the value of the AI. So
Yeah.
people have been saying, well, it helps with advertising, which is a $1 trillion market. It's already been gaining traction in the meta calls and stuff like that. But a new thing is Grok 4.2, which has not been released yet. XAI's Grok 4.2 has made money on trading. So the top pink line, they started with
Yeah.
$10,000 of real money in
Yeah.
something in the mode, 4 different modes, new baseline, monk mode, situational awareness, or max leverage. So monk mode is protecting your capital. I'm trading to try and
Mm.
protect my capital. Situational awareness is I'm getting in some feedback about what to do. So you can see it was the pink line is mostly flat from the beginning of November 19th out until about early December, flat, holding money, which is huge because every other model,
Hmm.
OpenAI, DeepSeek, Gemini, are losing money pretty steadily, right? And the
Yeah.
old Grok 4 model lost money
Yeah.
like crazy, the bottom black line. So the
Yeah.
Grok model from 4 to 4.2 goes from worst to first, right?
Yeah.
But it's flat for two weeks, which is huge because nothing else was flat, right? And then it got a big jump in beginning December and another big jump there. So a jump around. So 3 jumps against 2 pullbacks, substantial pullbacks. So it's making money in a trading mode. It's using 10 to 20 times leverage. All the models are using 10 to 20 times leverage. The reason is the guys who are running this system are working with this new kind of crypto trading thing, hyper liquidity, where they make new derivatives, super call options or super put options that multiply the risk. So they're playing with really risky stuff the whole time. They can release all the trades, so it's totally transparent. You know what they're doing before, you know why they're doing it, and you see what's currently active. So this trade is all out in the open. So there's no gaming it because it's still ongoing. The 2 week trading period where they do the competition ended, but now they're still trading real money, still doing stuff. So it's lost a bit of money, but it's about odds, right? Am I reducing the chances of missing? It's like baseball. A great hitter can hit 400 40% of the time. A okay one 30% of the time, a really bad one 20% of the time. And a great hitter can hit 50 home runs or like 1 in every 3 games for a season, right? Um, a okay home run hitter 1 in 10. So you can think of the big jumps like home runs. It's getting these big
Hmm.
home runs and it's getting on base enough to hold its
Hmm.
own as keeping the downside risk management on it. So I'll go. So this is real trading, and they've
Yeah.
done multiple trades per day. And I'm going to compare it to a roulette as well to kind of get a sense of what it is. Go ahead.
Yeah. Total cross competitions made $4,800, but you started with 10,000. So you 50% your money.
Right.
So if you started with 100 grand, you make 50,000. If you put a million, you made 500,000. Like, I mean,
Yeah.
it's crazy. And then, like you say, it was the one that's flat. Everyone was falling. And then it jumped and it jumped and jumped. So something about this model works. And so are you now saying that because a Grok had the largest compute, it was smarter than the others?
Right.
Simple as that.
They've done something fundamentally in their model with more training because they have the most compute on the Grok 4.2. They have more data. So they've cracked this real world problem in a substantial way. And there's value to
Gotcha.
this trading is that they're
Yeah.
doing day trading. And day trading, I think in the next slide I discuss it. It's a 10 to okay, well, this is again the roulette wheel thing. So they give you why they did it. So not just that it's like I'm doing this thing. They're explaining why each of the models explain why they did the trade.
Yeah.
So it's
Gotcha.
not random chance, but against a high odds thing. Roulette, people have played roulette, 36 numbers, and then often a 0 or double zero, so 37, 38 numbers. And the chance of winning on a number bet is like 35 to 1. And then
Mhm.
a split, I bet two numbers at the same time, 17 to 1. And then betting three numbers is 11 to 1. So them going 10 to 20 odds is like they're constantly playing two number, three number bets. So they have high
Yeah.
confidence they can do it. They can go up, for or against. And then next slide. If someone was playing roulette and you're just playing these high number bets, you would expect on a bankroll of $500 to go bankrupt in about 250 spins of the wheel, right?
Okay.
If you start with $500. So if I'm betting minimum bet size of $10 or like 2% of my bet, I would expect to go to bankrupt in 250 spins. So
Mhm.
they are not going bankrupt despite doing these really risky bets. So then it's sufficient to say, like, is the statistic significant? It's like I'm watching someone on the roulette wheel
Always winning.
always winning, right?
Or not always winning, but
Not losing, not going
it's
bankrupt.
not losing
Right.
like everyone else should be. Yeah.
And then
Okay.
going up.
So
Right?
they figure something out.
They
They
figure
got
something out.
something.
Right. Okay, go to the next slide. And then the program trading is for decades we've had some big companies with algorithms, regular software, doing all this trading against the market, and that's worth $20 billion of revenue per year, roughly. And
Yeah.
then it's going to
Yeah.
grow to $65 billion revenue. High frequency trading is within a few seconds, they're skimming all your trades. So they're
Yeah.
making money off of
Yeah.
you, right? So that's like
Yeah. But tiny little
microsecond trade.
tiny, but
Yeah, pennies off
microsecond
of
trades. Yeah.
everything. And then day trading is 10 to 20 billion dollars. They say 10 billion dollars, but I think it's bigger. It's just on the
Okay.
tools and software, it's 10 billion. So that is probably $100 billion market. So if they capture day trading, that is probably $100 billion market, which is 5 times the revenue of OpenAI at this point, right? So
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 just this one niche thing.
one
It's
niche
like
thing.
that's why AGI, that's why the smarter AI
Yeah.
makes a difference.
Right. And then if they
Okay.
expand out to different time periods, they master high frequency trading, they master longer form trading, then they
Yeah.
capture more and more of the trading market, trillions of dollars, right? So if
Yeah.
it's just like if I win some form of chess and then now I win all forms of chess or that kind of stuff, but this is a chess that's worth like trillions of dollars, right? So
Yes.
so it's huge money and
Wow.
it's a huge difference. There's another GDP
That's,
val score competition, which is
yeah.
can we do certain jobs? 14 years of experience in nursing, 14 years of experience in other jobs. The models are taking over, showing they can take over jobs. 60% of Grok 4, the old model. We'll see what Grok 4.2 does. The recently released, like today, OpenAI GPT 5.2, 71%. So can AI take over our jobs? And the answer will be yes, right? So
Yeah.
these are getting better and better. It's like leaps and
And
bounds. Yeah,
we're talking next year, 2026, if this continues. We'll
right.
see.
2026.
But
Yeah,
yeah.
right. And then
Wow.
next slide on that. So here's the value of it. Okay, so now this is going to electricity. So over the last 150 years, we went from inventing electricity, and then
Yeah.
by 1915, about 40 years in, we have about 35 terawatt hours around World War One, right? And then we go up nearly 1,000 times from World War One, 35 up to 32,000, right? So when we say that we're going to go up 1,000 times in energy from 100 gigawatts to 100 terawatts, this is the kind of thing that we're talking about. We're talking about something that took over a century to do before for electricity. It's something we're going to pack into about 20 years, 15 years. Like it's going to be fast that this happens. And the change, this 1,000x change, would just be, a shocking thing. So go to the next slide. Maybe you have any questions
And
about it.
which means, yeah, I mean, if electricity is correlated, and I'm sure it is with GDP,
Right. It is.
productivity,
Yeah.
performance,
Right.
absolutely it is. And so this is where Elon was saying that it's not about the existing GDP, it's about like
The future GDP.
10xing.
Right.
It's on, and then at some point it becomes like it's
Yeah.
too
For
much.
many decades, economists have had the GDP per kilowatt. So they say,
Yeah.
right, the unit of electricity, if I have more, you will be richer. So, yeah, and you generate more overall. So this 1,000 times increase, like I said, from World War One to today, that 1,000 times, the Industrial Revolution increased the world economy by over 100 times. So we went from $1
Yeah.
trillion to over $100 trillion. So these moves of 100 times,
Yeah.
1,000 times have happened. And if we could do a double, triple thing in that we go up, 1,000 times, 1,000,000 times, and the economy goes up 100 times, 10,000 times, where we'll have like 2 industrial revolutions over the
All
course
within
of
a
20,
decade,
30 years, right? A couple
20,
of
30
decades,
years.
yeah.
Okay, a couple
And
decades.
then the amount of energy right now in AI is only
Yeah.
200 terawatt hours. All data centers are 500 terawatt hours. So we're only using 1% of our energy for data centers. We'll be using it for, lighting our homes, doing other stuff, right? So if the AI part of it grows to what Elon's describing, the 100 terawatt hours, we're talking about like a 1,000,000 times scale up. The 100 gigawatts per year, the 8,000 terawatt hours is what she talks about doing that within like 5-6 years. The 100 gigawatts that could happen, and it would increase the amount of AI energy by 40
Needed,
40 times.
required.
Yeah,
You would need all of the current annual world energy each year to keep going. Well, where are you going to get it from?
right.
You
Right.
need to double your energy this year, double your energy next year, double of everything you're doing now.
Right.
The Chinese government's doing really well with that,
Right.
but the U.S. isn't. And so this is a way for the U.S. to leapfrog, go to space, get
Yeah.
free energy,
Yeah.
and then do it. It depends on how fast he can do it. And if you tell me that he can do this within 5 years, then as opposed to building power plants, building nuclear power plants,
Yeah.
building, that takes 3 years to get a regulation approved, all that.
Right. So each gigawatt, you can think of the nuclear power plant, normally takes like 5 to 10 years to make. So 100 gigawatts in 1 year is 100 nuclear power plants in 1 year. 300 gigawatts is 300 nuclear power plants in 1 year. If you go to 100 terawatt hours, that's 100,000 nuclear power plants in 1 year.
So that they're just not going to, nobody's ever going to do, that's like impossible.
It's impossible, and you couldn't get enough uranium, blah, blah, blah. So, okay. So
this is it. Okay. Getting free energy.
So I said,
okay.
GDP per person becomes GDP per AI chip. So if I have 1 trillion chips, it's like I have 100 times more than every person on Earth. So go to the next slide.
Let me pause there for a second, because I know, Brian, you told me this before. So you said that space-based AI is controlled really by SpaceX and XAI. But then I asked you, and you said, well, you said Tesla is going to be the one creating the chips because they create the terafab. They're going to be AI5, AI6, AI7. Then you said that the data center, 70% of the cost of a data center is actually the chip.
The chip, that's right.
So Tesla is going to have a significant revenue potential out of this as well.
Right. That actually it'll be equal to or slightly more than what SpaceX has. There could be some shifts in terms of the cut as things evolve, but it will be pretty close to equal or a bit more than what SpaceX has.
Okay,
and
so just want to make sure that it's not all SpaceX and XAI.
Not all
only.
SpaceX and SpaceX. It's also hugely Tesla. Each one of Elon's companies will be doing a heavy part of this. They won't be keeping out everyone else, because the only way the NVIDIA chips go, like if 1,000 times more power is up in space, everything has to move up in space. All the technology companies, everyone has to move, because the majority of action will be out there. It's like, how much is in Ireland versus how much in the United States. You migrated from Ireland, you go to the United States, it's where all the action will be. So everyone will pay the toll to SpaceX to take us there. And then Jensen will still love Elon, because yes, Elon will be competing with making terafabs, but TSMC, NVIDIA, everyone's going to move to orbit, move to the moon. It's like there's no choice. And people think, well, so much margin they'll be paying SpaceX. How much margin are they paying NVIDIA right now? It's like they pay it because they need it and because they'll make money. So there's no stopping it. So it's where everything will go.
Wow. Keep going. This is exciting.
This is about 100 times more electricity for air in the world to get to that first level, which is like that 100 times is like from Great Depression 1930s to today's power level of electricity. Lunar activation, the reply that Elon gave to me about 100 terawatts.
Hmm.
When you activate the moon, then
Meaning
you
to say
take
you
it.
build data warehouses on the moon.
No. You would make mining on the moon. You would make
Hmm.
the fabs on the moon. You make the factories on the moon, and then you would launch them with magnetic accelerators around space. So
Railgun? Is that what they called it?
yeah, like magnetic launch. It's like you have magnetic train, the maglev train, which
Hmm.
is like one in Shanghai, I think, from the
Yes.
Shanghai airport to Pudong, right? I've
Yeah.
ridden on it. And that kind of magnetic acceleration, instead of a train, I'd be having buckets that would launch things. So I don't need a rocket anymore. I just launch things into orbit because
Because
the
you're on
moon
the
has,
moon.
on the
Yeah.
moon, 1/6 the gravity, so 1/36 the energy. So then you can just,
It's just
launch
so
things.
it's so
Yeah.
logical, right? It makes so much sense. Why launch rockets from Earth?
Yeah.
You make it there and you just let it off, let it. It's like a helium
Let
balloon.
fly.
Let go of it and
Let
let
go.
it fly. Well, I guess it's not
Yeah.
flying, but let it
Yeah.
float into space, and then all of a
Yeah.
sudden you got your yeah.
Yeah. And then this is where, if Optimus was doing crazy work on Earth and keeping up with the space at this point, doing
Hmm.
huge effort, at this point, when they activate the moon and you get a 10 times, 100 times, 1,000 times bigger, then it's like there's no way you could generate the energy on Earth to match what's happening.
Gotcha.
Everything gets beyond it. The other thing would be that in my calculations, they will need hundreds of fabs on the moon, hundreds of factories on the moon, mining on the moon. Like they were talking about launching for the 100 gigawatts, 1,000,000 tons per year of satellite to orbit. From the moon going to 100 terawatts, we're talking about 1 billion tons. All steel production in the world is about 2 billion tons. So we're getting to that level of production in order to do what the thing we're talking about here. So the size of the facilities, the square mile area on the moon, about the size of Rhode Island or maybe the size of Taiwan. So it'll be something that you could see from Earth on the moon will be these facilities that will cover a section of it.
But are we talking like a century away for this to happen? Or are we talking, you keep saying 10, 20, 30 years?
Yeah, 10, 20, 30 years. Yes. So I think
Wow.
the moon part will take about 30 to 40. We can go to the next slide and we'll discuss the scaling of it. So SpaceX will launch about 30 megawatts, so like a few hundred satellites, a few hundred megawatts. They'll get up to 60 megawatts per launch. Then there's ways to push it up beyond that, but that's the relatively easy thing that Elon's talking about doing. So that means 3,000 launches of Starship for your 100 gigawatts. We've launched nearly 200 times for Falcon 9. So we're talking about a little over a magnitude more of the larger rocket. So 10 times more launches, 15 times more launches, 10 times more payload is what that is. So 3,000 launches per year. I think, right now they're at 3 launch towers, like one in Canaveral, one in Kennedy, so the two in Florida and then one in California for Falcon 9 launches. They're getting more approvals. They'll get to about, by 2030, 6 to 9 of those, but they accelerate, they could make more launch towers. So you want to have more launch towers to launch these things. And then after about 1,000 launches per year, you probably want to move it away from the air traffic because you'll be interfering with the regular air traffic flights too much. So it is doable. I've done the scaling on it in terms of like how fast it can be done. I think the 2030 to 2032 timeframe, Elon's pushing for 2030, but 2032 is doable. We'll see as they get more launch towers, as they build more facilities, the number of factories and things that they'll be around Texas and in Florida will just be crazy how much they'll have. So we'll see this happen in real time as they build this up. But roughly the number is you want to see about 3,000 to 5,000 launches. And then if you have 5,000 of the improved launch of 60 megawatts, that would be getting you 300 gigawatts per year. But then after that, you need to start moving off Earth because at your 100, 300 gigawatts, you're looking at 5 to 10% of all natural gas of the United States in order to make the fuel for your rockets. So then you're hitting these physical material limits that need. That's why you want to go away off of that. So then 3 terawatts per year, 3 billion 1 kilowatt chips over a decade. So that 3 billion chips is beyond what we normally be able to add on Earth over 40 years. So again, what would take a half a century, we could do in 5 years. So we can do this
Gotcha.
potentially 10 times faster. Again, 100 times more electricity for AI than we're using for AI in the world now. And the scale up is from, Great Depression to today in terms of like this 100 times move in AI. So then next. So launching from the moon. So again, as we discussed, no satellite launches. You're building the factories and fabs. So you're using the launches to deliver factories. Tesla bots will be involved. New mining equipment, electrically run, so made by Tesla probably, right? New mining
Boring.
equipment and boring, right? New equipment that will be doing the construction, doing the mining and stuff. So you need to make large numbers of those, because if I'm making hundreds of fabs and hundreds of factories there, that's a lot of work. I'm moving 1 billion tons of stuff. There's a lot of processing material, because I'll probably have to move like 10 billion, 100 billion tons of regolith, the moon dust, in order to get the billion tons of pure metal that I need, right? So the scale, again, of what we're doing here is really, really mind-bogglingly huge. The side effect is all the dreams of developing industrialization of space, everything has to happen in order for the AI flywheel to keep going. So then converting the energy to chips, 10 billion chips over a decade, assuming the 1 kilowatt chips, 100 billion chips, a trillion chips. So again, go ahead.
No, nothing. Just like, these are crazy numbers. 1 trillion chips over a decade. That's like,
Right.
okay.
Yeah. So then next slide. So this goes to some unit economic stuff where you can try and calculate tokens, and then token price will keep falling, energy. So it's really tough to estimate this. This is the aspect of the unit economics. How much money do we get from doing it? And then is the demand there for every person to use 1 trillion tokens? Or is it not the person, but the company that's applying things to the person, where people are thinking like, oh, it's cost me like $1 to get 1 million tokens or something like that. If the tokens drop to a penny each or something like that, then, so there's a bunch of analysis around actual supply, the revenue part of it, to maintain the unit economics of it. The benefit of going to the moon, though, is that we save 10 times on cost. What would have cost, $1 trillion end up costing 100 billion, because I'm doing it from the moon and at larger scale. And you could even further improve it, but at least a 10x improvement in cost, which means it's easier to keep going because we're just making it cheaper.
Wow.
Okay, next slide. Again, this is a ton of material. So in terms of tons of material that we do about 10 billion tons of crops per year. We do certain sand, gravel, cement things at the 50 billion tons per year. This is what civilization uses. 2.6 billion tons is iron ore, 4 billion tons is cement. So if we're building 1 billion tons of satellite, that's a lot of stuff. But conversely, think of each of the B3 satellites as a Model Y. 2 tons of satellite is about 2 tons for Model Y. So we make 2 billion cars. We can make 100 million cars a year. So making 100 million satellites of that size is, a conceivable thing.
Conceivable.
Yeah. And then how much crude oil. And so this is the size of the panels. They'll end up being bigger than this. This is still light enough for
Who's making this? This is a solar panel?
Solar panel, yeah.
Who's going to make this? Is it Tesla?
Tesla has vertically integrated. So Tesla has made at least 100 megawatts for the nearly 10,000 satellites that they have up there. The version V2 Mini.
So you're saying SpaceX did it?
SpaceX did it. I think that they get some suppliers from Taiwan or other things for the solar, but they do a lot of the assembly and the building of their own thing because no one else could do it. So they took over the supply chain. I believe it's gone in-house on that. And for this other scaling, yeah, go ahead.
Yeah, so you don't think Tesla will need to be the one to make the solar panels? SpaceX will own that business?
I think they may work together on it because Solar City part, they need to spend like for 50 gigawatts, that's of regular Earth-based solar, and they're not that different because again, Everything, in order for this to work fast, everything has to be as much the same as possible. So they just make it lighter. So China makes 70% of the world's solar panels, right? The largest factory there makes about 50 gigawatts per year of solar. They make about 600 gigawatts per year total on that, which if you put into space is the numbers that we're talking about, right? So already making it just on Earth, we just need to convert it over. So a super gigafactory of solar can make 50 gigawatts. That's what China has. And that's about a $10 billion factory. So I would expect it might be a partnership between Tesla and SpaceX to do
Okay.
it.
That's it. Oh my
Yeah,
gosh.
yeah,
Wow.
yeah.
This is blowing my mind. You've used, boy, you've done a lot of work, and you're a
Thank
pretty
you.
smart dude. So I think that
Yeah,
you these are all, you've calculated this.
right. And
Wow.
I'm thinking there must be like 50 to 100 people in SpaceX, Tesla, and other things working on these plans now. So they're
For
doing
sure.
detailed work on it. They're doing test models. There are probably even hundreds of people working on it, that they're all in on doing this thing, making the redesign of the satellite. So when Elon tells us all the numbers, there's like people behind it. I can just hear what he's saying and know, okay, this is what it's going to mean. This is what's happened. There's people doing detailed work to
Yeah.
actually, we're going to launch something next year that's going to start
Yeah.
doing this thing. We're going to scale up to this other thing. So we have to build the factories now. We have to start buying the land. Thus the IPO of SpaceX to raise 50 billion, $100 billion is to fund the factories. So it's like people think, well, Elon's saying he's going to IPO. Is he really going to IPO? Did they need to do that? It's like he
He needs the
has
money.
to. He needs
Yeah.
the money. He has to
Because he's
do it.
thinking big, and
Right.
the
And need the
reward is
money
so
next
big.
year to go. Yeah.
So just walk me through the timeline again, because I'm just okay. So you said that a version 3 of 100 of these data centers for testing could come out next year.
Right.
And then what? How long are we talking about to hit all those huge numbers you were just talking about? Like, when do we go to the moon? Is that like 10 years from now? I can guess. I wouldn't say it's anything earlier than that.
So if we back out from, say, a million satellites with 100 million chips in 2030, right? If we want to do that, then 2029 we need to be having the satellite factories. We'll have to have completed the 50,000 for communication by 2028. So we'll have 50,000 satellites done. This is already in the plans. They already got this
And
rolling.
that's in 3 years. Okay.
Right,
Okay.
but they already had that going. This is before the AI data center stuff. This was the communication plan of making
Yeah.
50,000 satellites. So then I would think 10,000 extra satellites of version
All right.
3
Yes.
around 2028. So my plan was 50,000. Okay. Maybe I do 10,000. Maybe I can ideally do 50,000 of AI satellites. That would be in 2028. And then scale up in 2029 to 250,000 and then to the million, right? If things went perfectly. If things go not quite as well, then only 1,000. Similar to the Optimus ramp of going 10 times. So 1,000 to 10,000 of the satellites in 2028, 10,000 to 100,000 in 2029, 100,000 to a
10x
million.
each year.
10x
And
each
then
year.
which is going to happen first then, Optimus or these data centers in space?
Optimus is happening starting next year with the million robots happening. And they will also be doing some distributed AI with the AI5 chips. I think they can do that with sample pilot production, that they can make enough chips because if there's 100 chips per wafer, they have this burst production stuff before you do real mass production, where you could get 1,000 wafers, 5,000 wafers per month, which would be enough to do what they need to do for
Optimus. So Optimus might come sooner and then quickly follows. Okay, so I'm just trying to figure out the, Tesla and SpaceX. Let's say SpaceX is valued at 1.5 trillion next year. Well, Tesla's already at 1.5 trillion now, and so it might be a little bit higher next year. But they're both basically starting the same point. And then you got Optimus, which is massive opportunity for Tesla. But then and chips, by the way, Optimus and chips, and then you've got AI data centers for SpaceX, which is, you just said, is even bigger. So and I'm just trying to figure out time wise. Like I'm in my head, SpaceX is huge, as you just said, but delayed later than Tesla.
Right. So I would see them like they tossed out 17 or 20 dummy satellites,
Last
without the
year, yeah,
electronics
this year, yeah,
this
with
year. So
yeah,
them doing a
just to test
batch
it.
of 100
Mhm.
satellites
Yeah,
to test stuff, to test maneuvering. I may want
yeah,
to do flying information, right?
yeah,
So there's stuff that they want to do at a
right away.
other guys have gone for. I've
Yeah,
launched one chip for StarCloud
yeah,
with NVIDIA, and then they're
Star
talking
Cloud and
about
video.
doing like
Yeah,
100 chips in one satellite, the one box, one
yeah,
rack, a year later, so end of 2026. But Elon can go
we'll
from,
just yeah,
because he did
he'll do that.
625 of the
Yeah,
direct to cell phone satellites, you
yeah,
know, like that, right?
like
So
that. Yeah,
doing a few hundred satellites for him is like I
nothing.
do two extra loads
Yeah.
and I'm there, right?
And he'll do that just to just get something out. It'll be ugly. We
Yeah,
just want to start testing things. Okay, I can
right,
see that for
right,
sure,
right.
but
And then
doesn't mean
so then I would think really scale would be around 2028. That's when
it'll be
they'll have the AI 6 or AI 7 chip, something modified. They may eventually want to go to AI 8, but doing some reasonable volume. The advantage of
Mhm.
Starlink, so they have the 10,000 satellites up there now, and they can put up another 50,000. So they have 2028, they have 50,000 satellites. Even though I'm not using data centers for Earth, I can use data centers for the Starlink satellites. For people who don't know the internet, you had all these fiber companies building out the internet, doing communications, and there were a company called Akamai and
Yeah,
F5, where they're doing the
yeah,
caching of memory, or so you can do nodes of compute nodes in space that would improve the performance and productivity and revenue of the communications. So they can do that by saying every fifth satellite, every 10th satellite is a compute node enhancing my Starlink network. My Starlink network is going to be making $100 billion, $200 billion a year from communications. And then they'll up level it with communication caching, with also some smart AI where I get
yeah.
like, I want to answer a question with AI. I do a
Gotcha.
compute thing up there. So their
Mm.
commercial 10,000 satellites, first 10,000 satellites with 100 chips each. So the first million chips would immediately be usable by their Starlink network, right?
Look at this. I found this. So this is November 1st, which is
Yeah,
like last month.
right.
Elon said, just finished a long AI 5 design review with the Tesla California and Texas chip engineers. It's going to be great.
Yeah,
AI 6 and AI 7 to follow in fast succession. He said that
yeah,
they'll be yearly.
yeah,
AI 8 will be out of this world.
right.
So he's hinting, isn't
Yeah,
he,
right,
that AI 8 will be what's going to be used
right. In high
for
volume, right.
in high volume for AI. It will be the one that's going to go
So,
out
and
of
so
this
if
world.
it's 2027, 2028, 2029, 2030, so it'd be 2030 unless they can accelerate into 2029. So if you're conservative, it's probably AI 8 in 2030 at high volume, unless they can, because they were talking about AI 6, AI 5 being only months apart. So we could
Hmm.
shift over and do like that's in 2027, 2028 is AI 7, and then 2029 would be AI 8.
This is
So
so
we're in
exciting.
that range of that,
Hmm.
right?
Okay. Well, first of all, amazing work. Thank you so
Thank
much,
you.
Brian. So obviously, what we're talking about is if you're a Tesla investor, you've got great opportunity because Optimus is coming, autonomy is here. Basically, robotaxis is, according to Elon, a solved problem. Can pump out cyber cabs. Then you got Optimus. We'll see if that is on track or late. And then the AI chips. That's what we're watching for. Elon said that chips. That's his things most. Now you've got AI data centers, of which Tesla's chips will play a huge part in. And then Tesla SpaceX is just going to take over and it's going to be
Right.
massive.
Right. It's gonna
So,
be massive. Yep. It's super
okay.
exciting. We're getting the solar system. It's just nutty. And that's also why he's not worried about, oh, if I go public, they won't let me go to Mars. Mars will be a rounding error. And also Mars will be another place to put AI data centers. So it's like Mars will happen. way bigger than he was talking about before. Because if you're
Well,
making
this will pay for it.
this
Yeah.
will pay for
At
everything.
this point, his economy will be multi-trillion dollars.
Yeah.
He can fund all this at this point. That's what he's doing it. So
Yeah.
he'll do it as a side project.
Right. That's right. Yeah.
He'll fund it himself.
That's right.
Oh.
Yeah.
Oh,
So it's very
thank you
exciting.
so much.
Yeah.
Wonderful. Appreciate you, Brian.
Thank
Bye-bye.
you. Bye-bye.
I've created a website that is the most comprehensive resource for the Tesla investor. Please check it out. Simply go to my website at herbertong.com.